Hey class, it's Mrs. Norris. We're going to take some notes for 6-4. We're going to start by looking at some special cases of parallelograms. And the first thing I want to point out to you that is if I ever tell you something's a rectangle or a rhombus, then I'm telling you that it's a parallelogram. And then all of those properties that we know about parallelogram applies. So now we're going to add some more properties to that list. It gets kind of overwhelming, so honestly the rest of this will most likely be open notes. As long as you're staying organized and keeping your notes organized, then you will be able to remember all these properties. So let's start with the rectangle. Once we know that a quadrilateral is a rectangle, we know that opposite sides are parallel and congruent and opposite angles and all the other properties of a parallelogram. But we also know that each of these angles are 90 degrees. So that's the first thing. You probably already knew that one. Second thing that we know about a rectangle is that its diagonals are congruent. And we're going to use that in just a minute, so don't forget that. Rectangle means 90 degrees at the corners, diagonals congruent. Alright, let's jump to the rhombus shape. If it's a rhombus, the first thing we realize is that all sides congruent, even the ones next to each other. So no longer do we just have the ones opposite each other are congruent, we have consecutive sides congruent. Okay? Alright, and the next thing about the rhombus is that its diagonals make perpendicular, or 90 degrees. That's important because we're probably going to be setting something equal to 90 when we see a rhombus. And the last thing is we recognize that the diagonal bisects the opposite angles. Okay, we'll talk more about that tomorrow. Okay, so we're going to combine our understanding of the parallelogram and these new shapes and try to answer these questions. Rectangle. Rectangle means 90 degrees at the corner. It means diagonals congruent. Okay? What is BD? BD is a diagonal. And since it's a parallelogram, we know that if that half is 6.5, then the other half also has to be 6.5. So the first thing I'm going to do is remind you that this half, or BE, is 6.5. Then we're going to go back to the question, which asks us to find BD, which is the entire diagonal, or 13 inches. When we get to CD, CD is the side opposite AB. Since a rectangle is a parallelogram, we know that this is 5 inches. AC, number 3, is asking us to find the distance for the other diagonal. Since the first diagonal was 13 inches, then AC has to be congruent to the first one, so it also has to be 13 inches. And AE is the half of the diagonal down here. Since we know that each of the 4 pieces are cut into 4 congruent parts, we can say that this is the same as the original given, which is 6.5 inches. Okay, let's jump to 5 and 6, which is a rhombus. You can look up for this, but what are the 3 things you remember about rhombus? Perpendicular diagonals. They bisect opposite angles, the diagonals do, and also all 4 sides are congruent. Let's start with looking at the picture, and even without reading the questions that it's giving you, let's just figure out what we know. We know several things. We know that this is equal to this, which is equal to this, which is equal to this. That tells me that this expression is equal to this expression. Writing out the algebra for that, we get 3x plus 4 equals x plus 20. Solving for x, we get x equals 12. Once we know that x is 12, we can plug that back in for any of the questions. Which one of the questions asks us to find or use x? Number 5. Number 5 is asking us to find KL. So even though I don't have anything written here, I know that KL is the same as this one. So I'm going to plug x in, get 32 for MN, which means KL is also 32. The next thing I'm going to do, or recognize what they want, is M and K. Back to our picture, let me erase all these markings. Since this little guy right here, you may not understand what they're trying to tell you. They're referencing this corner angle here. First thing we're going to use is that 90 degrees. So we're going to set 9y, which is the angle formed by the diagonal, equal to 90 degrees, and get y equals 10. Once we get that y equals 10, we can plug it into this expression. And we can get that this little angle right here, which is the one they're pointing to, is 2 times 10 plus 5, or 25 degrees. Where is angle MNK? MNK is the big angle here. MNK. And since we know that the diagonals of a rhombus bisect the corner angles, or the opposite angles, I can say that this angle was 25 degrees. This one right here we calculated was 25 degrees. So the total for this one is 50 degrees. Okay, at the top of page 2 you'll see a graphic organizer. We're going to make another one of these tomorrow or in the near future, so we'll be kind of summarizing everything, but let me just show you how it flows. We start with parallelogram. Once we get parallelogram and we know all the features of that, we can have two special cases as long as we know that it has meets the criteria for these two special cases. And then once we know that that's true, as long as it's both of these, check mark, we have the most special case of all, we get a square. We're going to take a minute and show you how to prove that this shape is in fact a square. We're going to use the rules of a rectangle and the rules of a rhombus and combine the two to prove that it's a square. So the first thing we're going to do is take the diagonals, show that they're congruent. The diagonals, remember, are the ones that connect to the corners. In our case, remember I'm always asking you to name these. We're going to say JL, or prove that JL is congruent to HK. Remember, in order to prove congruency, we need to find out how long they are. So let's go back to our picture for a minute. JL is this long. What if I create a right triangle using JL? Can you tell me how long it is, and which theorem will you use to find this length right here, or JL? Okay, so if we go back to our picture and we want to know how long something is, we can try to memorize the distance formula, or we can remember that the distance formula is the same as the Pythagorean theorem. Okay? So we're going to count blocks. We're going to get 1, 2, 3, 4, 5, 6 on this side, and 2 on the bottom. And the same can go for HK. We'll do that one in just a minute. So JL is equal to the square root of leg squared plus leg squared. That's how we're going to find JL. When we plug in 6 squared, we get 36. 2 squared is 4. We get the square root of 40. When we're finding HK, we're going to make another triangle. Let me switch colors here. So I'm going to go over here to back to the picture, and for finding how long HK is, we can use the distance formula, of course. We can go ahead and draw another right triangle and count blocks. That's 2. This one is again 6. And we can find HK using the Pythagorean theorem again, because HK is the hypotenuse. So we write HK equals the square root of leg squared plus leg squared. And we get the exact same thing, or the square root of 40. Once we say that HK equals the square root of 40 and JL equals the square root of 40, we've proved that the diagonals are congruent, because their lengths are the same, which means that we have a rectangle. Alright, what's the next part of the problem asking us to do? It's asking us to prove that they're perpendicular and bisectors, which are two different things. Step 2 is to prove that the diagonals are bisecting. So I'm going to switch back to red. Step 2 is to prove that the diagonals are, not bisecting, perpendicular. How do we prove that? We find the slope of each diagonal and we compare them. We're going to find the slope of HK using the same numbers. How far did we rise over run for HK? I still have the numbers up there for you. Well, we rose 2 and we ran 6. which is the same as positive 1 over 3. In other words, when I went from here to here, I went up 2 and over 6. I just drew my triangle down below. Up 2 over 6. Simplifying that using pre-algebra, we get 1/3. Let's do the other slope. Let me erase this one. If I need the slope of JK now, right here, let's talk about what happens from JL, I go down 6 and right 2, negative 6, right 2. I go down 6 and right 2, so my slope for JL is down 6, right 2. I counted. You can always use the slope formula if you want. I get negative 3. What's the relationship between our two slopes? Are they the same? Are these lines parallel? No, they're not the same. They're opposite reciprocal. Therefore, HK is perpendicular to JL. And the last step in this, step 3, is we are going to prove that they bisect each other. So we're just going to prove that the diagonals have the same midpoint. And I will walk you through this on a quiz. I will always put phrases to tell you what to do. Diagonals have same midpoint. That proves that they bisect each other. So we're jumping back a little bit. Midpoint formula is the same as the average, remember. It's where you add your x's and divide by 2, comma, y plus y2 divided by 2. Okay, this is the formula we're going to use of the diagonals. So we're still using the same 2 points. So back in my picture here, we're finding the midpoint of HK. So we're going to add 0 plus 6. Those are my x's, and divide by 2. 0 plus 6 divided by 2. And add our y's. We're going to get 4 plus 2 divided by 2. Okay, this is for HK. Midpoint. We're going to get 6 divided by 2, or 3, and 6 divided by 2, and 3. So we're going to get a point of 3, 3. Let's go over there and put that on there. See if you guys think we did that right. If I plot the point 3, 3, is that the midpoint of that line? Absolutely. And because I'm running over time here, we're going to also calculate the midpoint of JL, which is 4 plus 2. The midpoint for JL is 4 plus 2, or the 2 x's divided by 2, and 6 plus 0 divided by 2, and you're going to get the same thing, 3, 3. Alright, so we get 3, 3 is the midpoint for both. They're the same, so it must be a bisector. Okay, your homework is to try to do 7 and 8 on your own. You may have to attach paper if you need to, fine, or you can just write small. When they want you to prove the diagonals are congruent for this one, you can just use, you can regraph it if you want to, and use the Pythagorean theorem, or you can try using the distance formula. Okay, so you're comparing AC and BD for this one. This is the work I should see, and the numbers you plug in are either counting or using the distance formula by subtracting. For number 8, it's asking you to prove they're perpendicular, so I need you to find the slope of AC. Okay, either counting or using the formula, and compare that to the slope of BD. Make sure they're opposite reciprocals. Okay, that's how you prove perpendicular. And then in order to prove bisectors, you're using the midpoint of AC and the midpoint of BD, and showing that they are, in fact, the same point. Okay, this is your template. You fill it in. See you tomorrow.